Today we're going to start doing some more difficult differential equations. So what I mean by that is you're going to start to notice that we've got x's and y's that we're dealing with. So the first thing I'm going to do is go ahead and rewrite my dy or my y prime as dy over dx. And then I'm going to look at it as such. The first rule in solving any differential is a separate. Before that had been pretty easy. We just multiplied by dx on both sides. But now we have y's on the right-hand side. We're going to actually need to move that to the other side. You can do this one just by simply cross-multiplying. So you get 7y dy equals x to the 1/2 dx. Once your variables are separated, then you're ready to integrate. Just integrate like normal. This integral says that we are integrating with respect to y. So I just raise it by 1 and put it over that power. I can put plus c. It's not necessarily, we're only going to need 1 plus c. So then I have x to the 3/2 over 3/2 plus c. To simplify this, I could say this is 7/2 y squared equals 2/3 x to the 3/2 plus c. The only thing else you could see happen is they could make these all whole numbers by multiplying by 6. So I could take and multiply everything times 6, and times 6 on the c is still going to create c. So I end up getting 21y squared equals, this would be 4x to the 3/2 plus c. And then if we want to make it look more like a standard type form, we would put 21y squared minus 4x to the 3/2, and we could say this equals c. That's as far as I would ever take it. On this next problem, let's go through another one. This is dy over dx equals x times 1 plus y. Now in this problem, I'm going to have to divide by 1 plus y on both sides. So I will have this x, and I'll multiply by dx on both sides. I'll have an x dx, and this one I'm going to be dividing by 1 plus y. On the left-hand side, I have 1 over 1 plus y dy. Ready to integrate. This is an ln. I end up getting ln after y equals x to the second over 2 plus c. What I want to do now is, I will never get an answer to match this. What they're going to want you to do is they're going to want you to e both sides. What I'm doing is I'm actually taking e to this power equals e to this power. That eliminates the ln and leaves me with 1 plus y. Why do we do this? Because most of our equations, if they can, they will solve for y and get y by itself. So I get 1 plus y equals e to the x squared over 2 plus c. Now, one of the things that's very common in calculus is that they will all of a sudden have this big c that appears out front. And where that comes from is using your properties of algebra and splitting these things up and saying, well, this e to the x squared divided by 2 plus c is really e to the x squared divided by 2 times e to the c, because if I have the same base, I add my exponents. What they call this, so this is represented by a big C. So they'll rewrite this as just C e to the x squared over 2. And then the last thing they'll do is they'll solve for y. So they get C e to the x squared over 2 minus 1 as their final answer. This is how your answers are going to appear in the back of the book. This is how the answers will appear on that AP test. Alright, on these problems I went ahead and chose them just because of the words. We're going to write and solve the differential equation that models the statement. The statement given is the rate of change of p with respect to t is proportional to 25 minus t. What does that mean? Well, what it means is that if I write the rate of change of p, that would be dp over dt with respect to t, that's this, it's proportional to, so that's telling me I have some sort of constant times 25 minus t. So those are just words that you're going to have to get used to. Then from there, it's just like the other problem where we separate our variables. So I have dp equals k 25 minus t dt. So multiply by that on both sides. Ready to integrate. So I get p is equal to, I have to integrate this part. Well, you may want to make a u statement. Your u statement would be 25 minus t. So my du is a negative dt. So I end up getting k. Let's go ahead and put the k out front. The integral of, I've taken care of that part. I've got u, that's this part, and then I need the dt, so I need a negative du. So I've got a negative and a du here. So p is equal to negative k, u to the second over 2, plus c. So that is really just negative k over 2, that's my constant, u squared plus c. So my u again is 25 minus t. My next problem says solve a differential that models the statement. So this one says the rate of change of y with respect to x. So I've got dy over dx varies jointly as x and L minus y. So I've got a k, and then I've got my x and L minus y. Those just means they're multiplying those all together. This time a little bit harder differential y's here. So I'm going to have to divide each side by the L minus y. Now make sure you know that L is really just a constant. And then I have k, x, dx. Once your variables are separated, we can integrate both sides. This is an ln. This would be the ln of absolute value of L minus y, almost. But when you make that u statement, your du would end up being a negative 1 dy. So we're going to put a negative out in front to compensate for that. Equals k x squared over 2 plus c. So I'm getting a negative ln L minus y equals, let's move the negative to the other side, negative kx squared over 2 plus c. What I now can do is e both sides, as I've done before. Those cancel. So I get L minus y equals e to the negative k x squared over 2 plus c. That really gives me, again, that e to the negative kx squared over 2 times e to the c. That becomes my big C. So I'll put big C out front, e to the negative kx squared over 2. And on my left-hand side, I have y minus, or L minus y. So I'll solve for y now. And then getting y completely by itself flip-flops this back around. And I have my final solution. Alright, in this problem it says, write and solve the differential equation that models the statement. Again, I have the rate of change of n is proportional to n. So what is that? It's talking about the rate of change of n, and it's talking about t. So I know I've got the rate of change of dn over dt is equal to k proportional to n. Well, I'm going to separate my variables, and this one looks kind of funny, but I'm going to have to divide by n on both sides, so I've got 1 over n dn equals k dt. And remember, k is a constant, okay? So when we go to integrate this on both sides, I end up getting ln absolute value of n equals, this just ends up being kx. Oh, let me fix that. I should have said kt. It's t because we're doing this with respect to t, plus c. What I'm now going to do is get rid of my ln by eing both sides, so those fall out, and I get n is equal to e to the kt plus c. Pretty soon I'll stop doing this, but I want to show you again. This is e to the kt times e to the c. Remember, this just changes into a big C, and so I end up getting n is equal to big C e to the kt. Now that's the equation we're going to be using. Now what we were supposed to do with this is plug in some of these things. So I know that when t is 0, n is 250. So let's go ahead and look at that. So when n is 250, I'm just taking this equation and putting those things in. I have c e to the, this would be k times 0. Well, that would mean that c e to the 0, well, that's just 1, so c is equal to 250. That allows me to write the more specific equation, n equals 250 e to the kt. Now that'll allow me to figure out what's the value of n when t is 4. So n is actually equal to 250 e to the k times 4. One of the things you notice I'm missing is the k. So I need to actually go back and figure out what k is using this 1 and 400, and I forgot to do that first. So I can't jump to that step yet. I need to plug in 1 for t and 400 for my n. So I'll put 400 in here. I'm going to have to write a little smaller, so I get 400 over 250 e to the k. Well, I have to ln those sides to get rid of the e part. So I get k is equal to the ln of 400 over 250. That reduces down to be 8/5. Now I have the really specific equation. N equals, remember c is 250, e to the k is ln of 8/5 t. And now I can plug in 4. I will tell you that ln of 8 over 5 is the decimal 0.4700, and then I'll take that times 4. Use your calculator to get this answer, and you'll find that n is approximately 1,638.4.